So what do you need to do to take your backpack sprayer from this to this for less than $100? So what are the components we're going to need in order to get this done? Well, the first thing we're going to need is some kind of power source. I'm going to use a DeWalt battery pack, and I'm going to explain a little bit more about that later. And then of course we're going to need a pump. So there we go. The question is, how do you connect this to this? So let's look at some other components that we're going to need. So the first challenge is, even though the label says this is a 12 to 24 volt pump, I'm not sure that it is, because all the specs that I saw online said it was 12 volts only. And in any case, if down the road I want to swap this pump out for a different model that is only 12 volts, I need to transform the voltage from 20 volts down to 12 so that I can be sure that this pump isn't going to run very, very quick for a very short period of time and then let out a puff of smoke. And that's where this little guy comes in. Okay, so this is a power regulator, transformer, whatever you want to call it. 8 to 40 volts in, 12 volts out, 3 amp max. So that's this guy, right? DC to DC converter, very simple to wire up, yellow black, red black, in and out. Now this came with this guy, and this is sold online. You can get them on eBay, Amazon, all the stuff that I got on this table here I got from Amazon. I'll put the links down below. But this is a Hot Wheels battery, sorry, a Power Wheels battery connector. And this is designed if you want to use your power tool battery packs to run your kids' Power Wheels electric car. So these two came together in a kit on Amazon, and it works like this. So there it is. It's just clicks in. You've got the screw mount holes, and you've got negative and positive power out, which will go to this, and that will give you your 12 volts from your 20 volts. Now you can use any kind of battery. They make these Power Wheels adapters for all of the major battery platforms: Milwaukee, Ryobi, Black & Decker. I just have a lot of DeWalt 20 volt battery packs, so that's the one that I'm going to go for. You'll have to check if you go with a different battery manufacturer, because not all of them included this regulator, so you'll probably have to figure out the regulator on your own. So let's talk about the pump real quick. So this pump is 2.5 to 3.5 amps, 12 volts, 35 psi. It puts out 3.6 liters, which is just a hair less than 1 gallon a minute. And again, this will be on the description below. And it was only $23 on Amazon. So the key is, whatever pump you get, is you obviously want to make sure that the hose connections are going to work, and we'll talk about that later. But you also want to have a pressure switch on the pump. So the way this works is you bring power to the pump, it'll power on for a second till it builds pressure, and then it'll switch off. And then when you pull the trigger on the wand, you'll relieve that pressure, and the pump will just kick on and run, and it should run nice and steady. So that's the diaphragm pump piece. So we're going to have the pump, the Power Wheels connector with the battery, the converter, and now we need to talk about the next piece in the circuit. So as everyone who uses lithium-ion batteries knows, you cannot fully discharge a lithium-ion battery pack, right? If you fully discharge it, it's done. So this presents a problem with this setup, because as it stands right now, you could run this pump and run that battery all the way down to 0. So what we need to have is an over discharge protection circuit wired in, and the great news is they are super cheap, and I will put a link in the description down below for a video that explains how this little guy works. But basically you've got voltage in and out, and then you have an LED here, and you basically set the set point for the voltage, and when the battery discharges to that set voltage, this circuit will kill power to the pump. And so you can set that for whatever you want to, and again, that he does a better job of explaining that in the video that I'll link. But that will prevent you from over discharging your batteries and killing your $100 battery packs. Something else we're going to need is a fuse. So I just went with one of these. It's a 5 amp fast blow fuse, and that's going to go right after the battery. So as soon as the incoming power comes in, we'll have that fuse in line before the pump. So if anything goes wonky with the circuit, it'll kill power to the whole circuit. And the next thing we're going to need is an on-off switch. So this on-off switch has an LED light ring on it, and you can wire this in several different ways. You can wire it in to where it's on as soon as you plug in the battery. You can wire it into where it's on when it's off, and then when you switch the switch on, it lights up to show you that you switched it on. What I'm going to do is I'm going to wire this in to switch on the LED as soon as I plug the battery in. So I believe what I'm going to do is I'm going to wire it in after this board to turn the pump on and off, simply because it will give me a quick indication that everything in the circuit is working, because I'll have the LED will light up, and then I can switch the pump on and switch it off, understanding that the circuit will be hot all the way to here as long as the battery is connected, but I can still pull the battery out if I needed to. So that's how I'm going to do it. At least that's how I'm going to do it to start with, and we'll see how that works out. And then the last thing we're going to need is something to put all the electronics into. So this is the circuit I'm going to build, right? We've got the power pack to the power wheels adapter, fuse, voltage converter, over discharge protection circuit board, the power switch to the pump. Okay, and then we're going to put all of the components in this box, right? And this box has a rubber gasket seal on it, so we'll be able to get that nice and tight. I think I'm just going to double-sided sticky tape this stuff down. I've got my cat jumping around in the background. I'm going to drill a hole to put the fuse in so that it's accessible from the outside if I do pop a fuse for some reason. And I'll be drilling a hole to put the on-off switch in an easily accessible position. So that's what it's going to be when I get it put together. So let's talk about some components costs. Packet of fuses, the fuse holders was $7. The switch, including the wiring harness, $10. The low voltage protection circuit board was $13. The DeWalt Power Wheels adapter, which came with the voltage inverter, converter, whatever you want to call it, that was $22. The pump was $23. The waterproof project box is $8. And I also bought on eBay a sheet of ABS plastic. That was $15. And I used that to build a platform on the frame here to support the pump and the project box on the other side. So total cost is $88 for all of the parts. And then my Field & King 4-gallon sprayer, I think that was like $85. So you might ask yourself, well, why in the world would you go to all the aggravation of making your own 4-gallon sprayer into a battery powered sprayer? Well, there's two reasons. First of all, I bought the backpack sprayer and I quickly figured out that the amount of pumping that it takes, and I've got 17,000 square feet of lawn that I have to get chem down on, and so 4 gallons an application, 1 gallon per 1,000 square feet, I need 17 gallons, and so that's a lot of pumping to get one application of product down. The other reason is you pump up your battery sprayers that you can buy, and there's a lot of them out there. They run anywhere from $200 to $500 depending on what model you get. And the problem with those is, if something goes wrong with it, the pump, the parts, they're proprietary. And the way I look at it is, I can find these generic diaphragm pumps all day long on Amazon, eBay, and if the pump, or when the pump dies, because it's inevitable, I can swap it out myself. And that's my thought process. Now, if I had to do it over again, would I just go out and buy a battery powered sprayer? Well, maybe. The other problem is you've then got another battery system and another charger, and potentially down the road you're going to have to replace that battery pack as well. So just for me, it just makes more sense to try to convert this, hoping of course that it's actually going to work. So we'll see how that works. So this is what I'm working on putting together. So Power Wheels adapter is right there, and that fits nicely up under there. I'll put the on-off switch probably on the front here. I'll just have to experiment with when it's on my back. Put the fuse holder up here somewhere too, and the wiring will run under here in the back, and then I'm going to put the pump here. As you can see, the hose is right there for the input and output. At least I believe that's the direction of the pump. We'll have to see. But anyway, that's kind of the working theory right now. So we'll have to see how that comes together when I start building it. And of course, the best laid plans of mice and men. So that's the directional arrow for the pump, which isn't going to work because this is the output port, which means that the pump is going to have to go in the other way around. So maybe that's better, it'll protect the pressure switch, but I'll have to route the hose into that side and out the other. But anyway, we'll play with it, get it wired up, and see if the thing works. So a couple of things to note. I went with the battery in this direction, and it could have gone in the other direction like that, except for the shaft here from the manual pump but I didn't want to hacksaw that off and it would have interfered, so I just went with it the way it is. And then let's have a look inside the wiring. I'm going to drop all the screws on the floor, but that's okay. So I did end up bolting down the power wheels connector. I also double-sided sticky taped it. I did screw this down too. You can see there. Screwed that down through the plastic plate that I put in. The circuit board and the voltage converter, I just double-sided taped that down, and they're not going anywhere. So I was incorrect when I laid it out and explained the wiring schematic before. The error was you cannot have the over discharge protection circuit board after the 12-volt transformer, because if you do that, it's never going to read anything other than 12 volts and it'll allow the battery to run all the way down. So the way the circuit is, and I'll do a wiring diagram for it, incoming power positive to fuse, purple wire, and that goes to positive in on the over circuit protector, and then the black wire goes to negative in. Then you've got power out, that goes to your 20-volt step down, and then from this 20-volt step down I've then got it wired to the switch and the pump. And like I said, the way I've got mine wired, the switch wired in, is that when I plug the battery in, let me see if I can do this. As soon as I plug the battery in, there it is, the light just lit up. And so it's reading 20 volts, if you can see that. Let me see if I can get a better light there. 20.4 volts. And then you've got these two switches. So it's set to shut off at 15.3 volts. That's my over discharge protection voltage. Okay, if you hold that switch down, it'll start to flash, and then you can change it. Okay, then the other switch on the other side is your differential switch. So that is when your battery pack discharges, the board clicks off, the board needs to see a difference of whatever the voltage is that you set here. So mine is set at 1.5 volts. So the incoming fresh battery pack has to have at least 1.5 volts more than the one that was discharged in order for the board to switch back on again, if that makes sense. And then I'm not going to get into actually how I wired the switch in. It's pretty basic, but I will sketch out a wiring diagram. I believe this wiring diagram is correct. Be sure to let me know in the comments down below. It's key to note that as long as the battery pack is plugged in, unless you have a switch wired in before that board, it will consume voltage. So if you leave a battery on here, it will slowly run it all the way down. So I'm going to disconnect my battery. So here it is all done. I decided to put the fuse holder up here just so it wouldn't get bumped and knocked off. I did wire it up so that when you plug the battery pack in, the LED turns on to show you that the circuit is good. And there it is. and then you turn the pump on, and that's that. Now you can wire that LED different ways, as I explained earlier. Turning it around, I extended the wiring from the pump, and then I put in male-female spade connectors so that I can disconnect the pump and swap it out when that fails, which it inevitably will. Moving it around, the hose on this Field & King is 3/8 ID, so you want to make sure, and this pump is 3/8 ID, that's why I got this one. I ended up putting a 90-degree elbow in it, which acts as a swivel as well. I just didn't like the way that this hose was coming out from the pump, and I was sure it was going to get busted off. So here's a quick look at the underside, so you can see bolted the electronics box down and the pump, and then back here is where I'm going to have to cut this out a little bit, just because that edge keeps catching on my belt. But yeah, works like a champ.